In this example problem, we're going to discuss a camera that has a CCD sensor in the back of it, has a fixed focal length lens, 80 millimeters, and the lens is mounted right now such that we get a focused image for a very distant object. We want to determine how we should move the lens in order that we can get a focused, usable image for an object that's 2.5 meters away from the camera. So a little sketch is perhaps useful here. We're starting viewing a very distant objects, and we're not on the mountain, we're far away. And here's our sensor in the back of the camera, here's our lens, and we have an image distance that we'd like to know right now. We want to know where this lens is mounted such that we get a focused image. Well, with the lens equation, 1 over the object distance plus 1 over the image distance equals 1 over the focal length. We're very far away for our object, so essentially we're an infinite distance away. I'll just put approximately infinity. So 1 over approximately infinity is still a very small number here. So we get 1 over di equals 1 over f is the net of this, and we have that focal length, 80 millimeters. We'll use 8 centimeters, but that's going to be our image distance, 80 millimeters or 8 centimeters. I'm going to choose to use centimeters for my common unit in the calculation. So now we have a different object, and this object is 2.5 meters away from the sensor. 2.5 meters away from the sensor. So if we would sketch that out here, here's our new object, no longer the mountain, but something and these two are not the same scale in sketching. So our object here is 2.5 meters away from the sensor. It's not that distance away from the lens. This object is 2.5 meters away from the sensor. We have a new image distance now. The lens will be in a new position in order to focus this new object. Well, what does the lens equation tell us about this? 1 over do, the object distance, 1 over di, that image distance, equals 1 over f. To find the object distance, object to lens, we're going to have to start with 2.5 meters or 250 centimeters and then subtract this image distance. Do is from the object to the lens, not from the object to the sensor. So we have a calculation involved here. 1 over di, again that di is unknown, and our focal length is 8 centimeters. So how do we proceed? Well, we've got our di in the denominator. That's inconvenient. So I'm going to multiply by the least common denominator, and that happens to be all 3 denominators multiplied together. So I'm going to multiply every term by the quantity 250 minus di, and 8. That's our multiplication. Well, when we do this to this first term, the 250 minus di's, those will cancel. What I have here goes up in the numerator. So those will cancel. That'll leave me with 8 di. When we multiply in the second term, the di will cancel, and I'll have 250 minus di, that quantity, times 8. When I put that this multiplier in the numerator here, the 8 cancels, so I get di times 250 minus di. So we need to clear out the parentheses, distribute. So when we take 8 times 250, that's 2,000, minus 8 di. And here di times 250 minus di squared. We have a quadratic equation. So let's put that in a more standard form with a positive coefficient for the di squared. And so I add di squared to both sides. The 8 di and minus 8 di have canceled, have added to 0. I subtract 250 di from both sides, and the 2 plus 2,000 stays where it is. Using quadratic formula, we have minus b, the b coefficient is minus 250, plus or minus square root of b squared minus 4ac. The 4 is part of the quadratic formula. The 2,000 is the c number, plus 2,000. And then we divide by 2 times a. The coefficient of d squared is 1. The 2 times a 1, and there's also the 1 here for 4ac. You should pause and work this out on your calculator. What I came up with after I did the square root was 233.45. minus a minus 250 creates a positive 250. So 250 plus or minus 233.45, and we do this numerator calculation, then we divide by 2. If I choose the plus sign, 250 plus 233.45, DI comes out to be 241.7, and if I would subtract that from 250, I would find the object distance, 8.28 centimeters. Let that percolate in your mind just a little bit. And then if I choose the minus sign, I get DI as 8.28 centimeters, and the distance of the object from the lens is 241.7 centimeters. Which is correct? Well, really, they're both kind of correct, but one is better than the other. One will produce a usable image. Let's take a look at the magnifications. If I use the plus sign result, I have minus DI over DO. The magnification will be minus 29.2. If I use the minus sign result, minus DI over DO, and I get magnification of minus 0.0343. Remember, we're trying to fit this the image onto a sensor in a camera. So if this is a person, we need to shrink the size of the image compared to the object. So this is the reasonable answer. It is the minus sign that gives us the correct position of the lens. The other thing to think about, if you choose this, if you think this is the reasonable answer, that DI is 241.7, that means that this lens needs to be 2.4 meters away from the sensor. It was 8 centimeters. Now we're trying to force it to be 240 centimeters from the lens. So that is not going to work. So the physical result, the reasonable result, is that the image distance is 8.28 centimeters. It is true that this lens can be in both positions and get a focused image. This position gives us a small focused image. If we would put the lens here, we get a huge focused image that does not fit onto the sensor. So pause this and rewind if you need to go over some of my verbal explanation again. Run this by your physics instructor if you have questions. Keep practicing, and if you want some more practice videos, they're listed at physics.gpclements.com, astronomy.gpclements.com. There's nothing to buy at these sites. They're free. You do not register. You just go ahead to those sites and you look at listings of videos that I've made and post on YouTube. Find the one that's useful for you, I hope. And if they are useful, please subscribe to my YouTube channel. Keep practicing physics problems.